Let us all remain standing as we sing the school song, Sabse Sundar. Please be seated. Good morning, respected headmaster, distinguished guests from the IISc and Talentspire, deputy headmaster, bursar, esteemed teachers, and all the students present here. It gives me great pleasure to welcome you to the DSSC and IISc Climate Change Program and Quiz Competition here at the Lawrence School, Lovedale. Today's event is more than just a contest of knowledge. It is an opportunity to engage deeply with one of the most pressing issues of our time. Why does climate change matter? Climate change means long-term shifts in weather patterns caused mainly by greenhouse gases like CO2 and methane. These trap heat in the atmosphere and increased by human activities such as burning coal, oil, and cutting trees. The effects of climate change are as follows. Rising temperatures leading to heat waves and health problems, melting glaciers causing sea level rise, threatening cities like Mumbai, Chennai, and Kolkata, frequent droughts and floods damaging agriculture and food supply, and vulnerable communities and biodiversity face the highest risks. I would now request Mr. Matthew John, the Managing Director of Talentspire, to address the gathering.
Greetings to all the dignitaries who are in the auditorium. Our chief guest, Dr. M. Rajivan, who is joining us online, principals, teachers, and dear students for whom this program is conducted, and all those who are joining us online from different countries and across various time zones around the world. Greetings to all of you. Climate change and environmental degradation is one of the major challenges faced by the occupants of this planet in the 21st century. Actually, the problem has been in the making for decades or centuries, maybe since the start of Industrial Revolution. But now it has reached alarming proportions and a level where it cannot be ignored anymore. So hence, it is important that the young generation, students, need to be alerted about this damage, and so that they can be part of efforts to correct this. As Laurentians, you're fortunate to live in the lap of nature, and you see the beauty of fresh green vegetation and trees all around, all the time. So you may not feel environmental degradation, the effects of environmental degradation and pollution. You're fortunate to do that, but to live here like that. But at the same time, Lovedale and Ooty is not a separate part. It is part of a connected world. It is part of the planet. And all those actions of those in other places affect hamlets like this also. So it is important that the young generation needs to be alerted on this thing, and that is the importance of this program. And there are those who claim that climate change is a natural process in the evolution of Earth, and it will happen. It is a cyclical process, and it will happen regardless of whether humans do something or not. It is not caused by human activities. There are people who claim that. And there is some element of truth in that as well. Climate change always, it happens. But it is only a part of the truth, okay? And then half-truths are always dangerous. So you need to be aware as to where it is coming from, the origins of climate change and environmental degradation and everything. So now I actually request you to please listen to all these presentations and actively interact with the scientists who would be making presentation in the later sessions. And from the facts, figures, and inferences which they present, you arrive at your own conclusions. Okay, you're all intelligent students, and then you will be able to arrive at your own conclusions based on facts, figures, and inferences. Okay, so please listen to these deliberations. These are among the best scientists in the world on this subject, and so you please listen keenly and arrive at your own conclusions and be part of the initiatives to stop this damage to our Earth. And the Divecha Center for Climate Change, the primary organization organizing this program, was established at the IISc with the financial support of Arjun and Diana Divecha Trust and Grantham Foundation for the Protection of the Environment. As Laurentians, you can be proud that Arjun Divecha is a Laurentian, and then it is with that trust's financial support that this Divecha Center was established, apart from that of the Grantham Foundation for the Environment. There are only three entities, organizations that are supported by the Grantham Foundation. So one is the London School of Economics, and the other is the Imperial College of London, and then the third one is the Divecha Center for Climate Change. So the importance of the Divecha Center all around the world. It is recognized. Their contributions are recognized. The scientists who are coming here, their contributions to this climate change initiative, it's immense. Divecha Center, their vision, their mandate is threefold. One is research, second is policy, and the third is outreach. So research, when you say research, they're among the best scientists in the world on this subject. That is research, and research activities are going on, and how nature can be brought back to its former glory, by arresting this problem. That is what they are doing in their labs. And then apart from that, they work on policy as well. They work with different governmental agencies and central government and different agencies across the world, and talk to them regarding policy. And then the third is outreach. So they have these outreach programs for young students, and that is how they came to this legacy institution as well, to talk to you and to make you aware of this problem. my organization, Talentspire. It is a collective of about 500 plus senior academicians, scientists, research scholars, and technologists. And our vision and mission is holistic learning. So these kind of activities are conducted in line with that. So this event is conceived as a prelude to a wider initiative, including several organizations at the national and international level, coming together to work with schools at the ground level. So, I know you must all be aware of NEP, National Education Policy 2020, by the Kasturi Rangan Committee. So we have had the privilege to work with Dr. Kasturi Rangan and many others who were involved in the NEP program much prior to publishing it in 2020. So as part of that, in 2018, we conducted a program here in the school also with a wide participation from the school and the students. Okay, and in 2020, the NEP was published. Okay, the first recommendation of NEP was to rename the Department of HRD to Department of Education. Okay, so that was done in 1 month. Okay, in July it was published. By August, the department was renamed as Department of Education for the Government of India. But then there are numerous other recommendations formulated by this committee, and implementing those policies at the ground level, it is not an easy task. Government's plan is to implement this in 10 years' time, from 2020 to 2030, 10 years, and we are halfway through. And there is a lot of work to be done, and we'll be working with government agencies and many national institutes to implement this, and as part of this, we have come here as well for that. So this event also is a part of that. And so now I will get to my pleasant duty of welcoming the dignitaries. So our chief guest is Dr. M. Rajivan. He's among the most appropriate people to inaugurate this initiative. He's the former secretary of Ministry of Earth Sciences, the former director of Indian Institute of Tropical Meteorology. He's 30 plus years of experience in weather and climate studies. And he's contributed immensely to the studies in weather and climate. And then when he was in charge of the meteorological department, it was modernized, and many systems to predict weather and climate change, it was developed during his tenure in the meteorological department. And he's an expert and respected worldwide on that. And he's a fellow of all 3 national science academies as well. So, and he's currently the Vice Chancellor of Atria University in Bengaluru, and he's the most appropriate person to inaugurate this event. Sir, on behalf of this gathering, I welcome you to this program. Dr. M. Rajivan, and we look forward to your talk later as well. And next is Professor Satish, Professor S.K. Satish. His educational qualifications and contributions to various areas in science, and particularly in climate science, I get so confused that it is so many that, I have a confusion on, what to mention here. He has got the highest science awards in India, the Bhatnagar Award, the Infosys Award, the American Geophysicists Union Award, and numerous awards. And he's a fellow of numerous science academies. And he's a well-respected, highly distinguished scientist in the world. And then he's also the chairman of the Veja Center for Climate Change, which is organizing this program. And he's also the Dean of Administration of IISc. Sir, on behalf of this gathering, I welcome you. Dr. Paramesh, he's an expert in health studies related to this climate change aspects. He's an expert in that area, and he is involved in many outreach efforts. Dr. Paramesh also will be having his talk later. Sir, I welcome you to this gathering on behalf of you. So now the President, the person who is presiding over this function, the headmaster of the institution, Mr. D.V.S. Rao. So we've been in touch with him and his team over the last many weeks. And then he and his team has promised all the support possible to conduct this event successfully. And then, I can't thank him enough for all the support which he has given for that. He and his team has given. So, sir, on behalf of this gathering, I welcome you to this event. And along with him, I welcome the Deputy Headmaster, Bursar, and the other teaching staff and all other admin staff to this gathering. And later, Dr. J. Srinivasan, he's also a very distinguished scientist in the field of climate change. He's the former chairman of the Veja Center for Climate Change. He will be joining us online in later sessions. In absentia, I welcome him to this event. Then along with us, there are two other special guests as well. Okay. One is Mr. Bebikuti P. Rajan. He is the principal of St. Thomas Residential School in Trivandrum. He took the trouble to travel with us all the way from Trivandrum amongst busy schedule to be part of this event. And then he is also engaging his students in these initiatives. Sir, on behalf of this gathering, we welcome you. A very senior journalist in India is traveling along with us, and he'll be part of all these initiatives. When I say initiatives, the initiatives are related to climate change and NEP as well. He's a senior correspondent with India Today. He was a senior correspondent of India Today, Madhubhumi, and many other leading media. And then he's traveling with us as part of his support in media for the initiatives of this. Sir, on behalf of this gathering, I welcome you as well. And I welcome all the teachers, principals, and all the dear students who are sitting here for whom the program is organized. Once again, I welcome everyone, and thank you, everybody. Thank you. Bye. Now I request Dr. M. Rajivan to formally inaugurate the event. Welcome, sir.
Good morning, everyone. Respected Headmaster Mr. Rao, teachers, distinguished guests, and dear students. It gives me great pleasure to be with you today at this important event on climate change and environment awareness being organized by the Veja Center for Climate Change for high school students at the Lawrence School, Ooty. I feel very honored to inaugurate this program. I feel deeply moved to see a school community, our future leaders, taking one of the most urgent challenges of our time. When we look back at human history, we see how generations before us faced great challenges like wars, famines, diseases, etc. They overcame them with courage and innovation. But today we face a different kind of challenge. This challenge is called climate change. It is about the survival of our entire planet, the air we breathe, the water we drink, the forests that shelter us, and the oceans that sustain life. We know due to increase in greenhouse gases, concentration of greenhouse gases in the atmosphere, global temperatures are increasing. The climate change is not just about rising temperatures. We see it in increasing heat waves over different parts of the world, melting glaciers, increasing sea level rise, more intense tropical cyclones, floods, droughts, wildfires, and even in the loss of biodiversity. The Himalayas, our water towers, are really shrinking. Coastal areas are facing rising sea levels. Farmers are struggling with uncertain rains. And the truth is, if we do not act now, the future generation, that means you, the young students sitting here, will face even harsher consequences. Some of you may ask why school should really worry about climate change. Is it not a job for senior government officials and scientists? The answer is very simple, because the schools where we are where awareness really begins. Children are the best messengers in our world. When a student learns to save, for example, water, to switch off the lights, to plant a tree, or to reduce plastic waste, they not only practice it themselves, but also inspire their families and also neighbors. So awareness is the first step to action. And action, when multiplied by millions, changes the world. India is a country blessed with rich natural resources, our summer monsoon rains, fertile soils, forests, and coasts. But we are also vulnerable to climate disasters like the recent floods in Himalayas, the severe cyclones that hit Odisha and Tamil Nadu, or the heat waves sweeping across North India. These are not just distant warnings. They are reminders that climate change is happening here and now.
Sir.
You want to mute us, sir?
No, because what you speak here can be heard there as well.
Who's SK service, sir?
So this has to be unmute.
SK service.
Unmute. Click on unmute, please.
No. Who's this, sir?
This is Dr. Just to check that whether we can hear you.
Diveja Center of Climate Change. Professor J. Srinivasan, former chairman, Diveja Center for Climate Change. Mr. Matthew John, managing director, Talentspire. Distinguished guests, members of the faculty, students of our school, and our students from visiting schools. A very good morning for all of you. At the outset, I extend my heartfelt gratitude to Dr. Rajivan for his thought-provoking inaugural address. His insights into climate change, modern satellite images, researchers found that Nilgiris has lost nearly 80% of their grasslands since 1848. In 1848, the grasslands covered about 1,000 square kilometers, roughly 1.6 times the size of Mumbai, and by 2018, only 200 square kilometers remained. Century-old bird specimens and naturalists' diaries guided scientists back to the very sites where these species were once recorded, revealing that nearly 90% of grassland birds, including the Nilgiri pipit, have sharply declined. These examples underscore why schools must become spaces where awareness translates into informed action through sustainable practices, environmental literacy, and student-driven projects. On the wider context, this discussion is also anchored in the broader initiative of forming an NEP Alliance of Excellence that is transforming schools through strategic partnerships. The alliance will connect schools with leading institutions like national science, research, and technology organizations, as well as regional bodies. Offer expert guidance and mentorship to teachers and students in implementing the policies and vision of NEP 2020 with a focus on critical thinking, experiential learning, and sustainability. Develop the school-level action models for climate awareness and NEP-aligned excellence, which can be scaled across the country. Encourage Inter-school collaborations where young learners work on projects related to climate action, energy conservation, biodiversity protection, and community resilience. Build partnerships, that is, to link schools with national science and technology institutions and regional organizations. Develop expert network support, teachers and schools guided in translating NEP 2020 vision into practice. Sustainability and innovation, that is, embed climate literacy, problem solving, and experiential learning. Hands-on experience, that is, to develop pilot projects in schools that can be replicated nationwide. Also to build strategy, also the strategic objectives can be to build student-led climate awareness campaigns, support schools with curriculum integration of sustainability themes, facilitate inter-school collaborations on energy, biodiversity, and resilience projects, foster 21st century skills, that is critical thinking, inquiry, action-oriented learning. And what would be the expected outcomes? A network of climate conscious schools aligned with NEP 2020, students as change agents in their communities, stronger social science, school science partnerships driving excellence and sustainability. By embedding climate literacy into the NEP Alliance framework, we not only prepare students academically, but also empower them to be responsible citizens and problem solvers for a sustainable future. Our diversity is our strength as a school, but actual growth begins when we welcome renowned organizations and distinguished individuals, transforming our scope and limit to be boundless. I hope all of you have a wonderful and enriching day filled with learning, inspiration, and renewed sense of responsibility towards our planet. Thank you so much. Have a great day.
I now request Professor S.K. Satish, Chairman Devesha Center for Climate Change, IISc, and Dean of Administration, IISc, to address the gathering.
Thank you. Good morning to all. Dr. Rajivan, Mr. Rao, Dr. Professor Paramesh, distinguished dignitaries, teachers, and students. I'm very happy to be here. In 2019, we have come here again. We are here this time to conduct this very important program. So you heard about Divecha Center for Climate Change, our mission and vision from Sri Matthew. So I'm not repeating the same, only to add that we also interact with high school students and college students to make them aware of the consequences of climate change because of the reasons mentioned by Dr. Rajivan and Mr. Rao. It's very important that schools and school students are important in this program. So we have started this interaction with the high school students in 2018 onwards, and till now we have interacted with more than 25,000 school students so far in various schools across the country. So just to remind you, you might have read from newspapers or some other sources. You might have heard about Intergovernmental Panel on Climate Change, in which, or IPCC, which many of us have worked in the past. And the reports of IPCC clearly states that we are already facing the consequences of 1 degree warming. You know that global warming is slightly above 1 degree Celsius now. And the things we are experiencing is extreme weather events, sea level rise, glacier melting, and so on. These are only some of the issues. And every time there is a fresh scientific evidence, it's only reaffirmed that climate change is inevitable. Why I say that? Because if we wanted to limit, according to Paris Agreement, we were supposed to limit the global warming to less than 1.5 degrees Celsius. But then we should have stabilized the greenhouse gas concentrations, for example, 400 ppm of CO2. That is already crossed. So this is an uncomfortable reality for all of us in this field. And this has forced us to set a new target of 450 ppm, which is the concentration target to limit the global warming to 2 degrees Celsius or less. Therefore, the world is currently striving is to achieve not only halting climate change, but mitigate the effects of climate change and adapt to the changes. Why? Because we are almost certain that climate change will happen. Now, only thing we can do is to reduce the effect of the consequences of climate change. Just one example, National Center for Climate Restoration in Australia, they released a report in 2018, and it's called a concept hot house earth. So this is a very scary scenario for all of you, because it may you may face in your lifetime. This is a term used to describe a scenario in which human activity causes a higher global temperature than at any time in the last 1.2 million years. So according to this, the predicted temperature increase by 2050 is likely to exceed at least 2 degrees Celsius. And the consequences are at least around 50% of the population, world's population, is likely to experience heat waves, which was mentioned before by the Honorable Headmaster and Dr. Rajivan, and at least 100 days per year. Now it is a couple of days per year, but now you will most likely experience 100 days per year. There will be heat waves in different parts of the country, or in fact the world. And major rivers in Asia, which are providing water to a large fraction of our population, are likely to be dry in summer season, with implication to water security for more than 200 crore people. And monsoon is likely to be chaotic. And you know, in India, agriculture is an important aspect for economy, our economy. And agriculture may not be practical, because unless we know when the rainfall is going to set and when it is going to stop, or how will be the distribution, you cannot plan agriculture. So that may become impractical at that time. So at least 100 crore people may need to migrate. You know, when there is a forced migration, it is not only physical, there will be mental issues also. So there are some research projects we are conducting now, is the effect of mental wellness issues because of the climate change. And these challenges are irreversible. That is the most important thing you needed to remember. You cannot reverse it back. On the time scale of people alive today, and will worsen in the decades to come. In my presentations later, I will tell you more about this aspect. And one more important aspect is health, which Dr. Paramesh will talk to you, and he will also tell you that with his more than 40 years of experience in this field, that school children are going to be the most affected. So only I want to mention that the health of our planet is linked to the health of each and every one of us. And this is called planetary health. This topic is called planetary health, and it is a solutions-oriented, transdisciplinary field and social movement focused on analyzing and addressing the impacts of human disruptions to Earth's natural systems and on human health and all life on the Earth. Understanding and acting upon these challenges call for massive collaborations, as mentioned before by both speakers, and across disciplines and national boundaries to safeguard our health. So studies have shown that sudden changes in temperature and increased number of extreme weather events provide an ideal breeding ground, which is conducive for virus modification and the emergence of infectious diseases. So this requires more studies, and we want collaboration from all of you. And before I close, I just wanted to remind you one more thing. We all have a responsibility to take action to prevent the climate from deteriorating further, as mentioned by the previous two speakers. One example is world was not prepared to face COVID-19 type of a situation. It suddenly happened. We were not prepared to face that. We all struggled. And there are similarities with climate change problem. It is a fact that world is not prepared to face the consequences of climate change, just like the case of COVID-19. I'm very sure about it. With more than 30 years of my experience in this field, I can tell you. So we hope that experience from COVID-19 pandemic would make the world leaders realize the serious implications of climate change and take appropriate policy decision. And policy decision we make now and in the coming years will have a significant impact on the future of this planet itself. It will need massive efforts from all of us, both at the individual and community levels, with the collaborative efforts from public and private sectors for the better health of our planet. This is the reason we always advocate that medical practitioners and climate scientists should work together to tackle such important global issues. So as I mentioned, in 2018, the Divecha Center started climate science awareness program for the benefit of high school students in different parts of India. And the program consists of lectures you will hear after a few minutes on climate change and the environment by eminent scientists, demonstration of methods for the measurement of air pollution and a climate change science context, which is in the afternoon. The main objective is to create awareness about various problems and issues we are going to face because of climate change among school students and its consequences also. So several of the high school students we interacted in 2018 onwards, they later decided to pursue their higher studies in the area of climate change. And thank you all, and wish you all a fruitful session ahead, and thank Lawrence School for providing this opportunity. Thank you.
Thank you, sir. Everyone to now disperse for tea. 9 to 11, excuse me. 9 to 11 boys will have tea in Info Center, while the others will have tea in Dining Hall. Everyone to reconvene here at 11:15. Thank you.
apply also. And this is an example of what will happen, various scenarios of sea level rise. You can see from this website also, but just to show you, I brought a 3-minute video. So you can see what will happen to different cities if there is a sea level rise of 2 degrees Celsius. If global warming is 2 degrees Celsius, what will happen to New York City is what is shown here. Please see the video for 2 minutes. Tokyo. I will continue from there. So this is how the consequence, and you can guess what will happen to Indian coastal region also. We have a very long coastline, and if water start coming in, sea level rise and water start coming in, there will be lot of areas which can go under the water. So now the question is, how do we know that climate change is taking place? So it's mostly the proxy is temperature. You can see that lot of modeling studies have happened. And if you see that by 2100, this is the change, 2 degree to 6 degrees Celsius. Previously, I told you that what we are facing right now, lot of extreme weather events or heat waves or sea level rise, glacier melting, all whatever we are seeing now is the consequence of just 1 degree Celsius global warming. Again, you may be thinking what is so important in 1 degree Celsius global warming, because we experience lot of temperature changes in different seasons. But 1 degree Celsius, what we are seeing here, is a global average temperature day and night. You know, you average from poles to equator and the entire world, day and night, irrespective of day or night. That is what is 1 degree Celsius we are talking about. So if you take the average temperature like that, it is 1.2 degrees Celsius global warming as of now. So that will be 1.5 degree we are now trying to avoid, but it's difficult because, as I said, it is already crossed to 400 ppm of carbon dioxide. So 2 degree we are trying to limit according to Paris Agreement. If every country follows Paris Agreement terms and conditions, then or commitments, we may limit below 2 degrees Celsius. But what we are talking about here is 6 degrees Celsius. So you can guess the consequences, how much disastrous it can be. So, but at least by 2030, 35 or 2050, that is why you are all coming in the picture. If 2050, if there is a disastrous change, then you are all be affected. And there are so many photos I can show you. 1914, this was Himalayan glaciers. 2004, it is not glacier, it is water. And why our planet is getting hotter, that is where I want to introduce you to a new species. And that is because of radiatively active species, and mostly it is carbon dioxide plus another species called aerosols. That is not very well known, but aerosols are any solid or liquid phase particle suspended in the atmosphere. It is called aerosol, and its size is 0.5 micrometer. This is not millimeter, micrometer in size. This is making it radiatively very active in the visible wavelength region. As you know, most of our sunlight is coming in the green wavelength region, that is 0.55 micrometer. And the size of the aerosol is typically around 0.5. So, you know, according to scattering theory, if you have studied in your high school studies syllabus, then when the size of scatterer is comparable to the wavelength of radiation incident, the effect will be maximum. So it can scatter the red color in the sunlight more effectively. That is why during sunset and sunrise you see that like red color of the sky. So there are several types of aerosols. You have a natural aerosol like simple dust, sea salt particles, volcanic dust, oceanic sulfate like that, and anthropogenic or man-made aerosols, you know very well, whatever is coming from industries or emission from transport vehicles, black carbon from biomass burning. That is one of the most important aerosol species because it can absorb a lot of radiation and consequently it can warm the atmosphere. And typical lifetime is several weeks to months, and it's also part of air pollution. When you say air pollution, aerosols are a part of aerosol system, is also part of air pollution, PM 2.5 and all you might have heard. That Dr. Paramesh will tell you more about it. And why it is important? Because as I said, it is mainly because of its impact on radiation. Not only incoming solar radiation, whatever is going from the Earth's surface, that is in the infrared region, that also can get affected. Because of that, it affects climate. It can affect remote sensing because when satellites see the Earth's surface, it is passing through the atmosphere. So it has to see the Earth's surface through the atmosphere. So anything which is suspended in the atmosphere can affect satellite remote sensing. And it can affect agriculture because it can affect radiation coming to the surface, so it can affect agriculture. And directly it can affect health. That in the next lecture you will hear from Dr. Paramesh. And as I said, directly by scattering incoming sunlight back to space and by absorbing sunlight, it can affect climate. And indirectly, as you know, clouds cannot form without aerosols. Whatever is the supersaturation or relative humidity you have, if aerosols are not there, you don't have a surface for this water vapor to condense. So you will not have clouds. So it can affect and modify the properties and lifetime of clouds. In 2014, World Health Organization classified suspended atmospheric particulate matter as a carcinogen. So that means it has a serious health impact also if you inhale. And air quality degradation is a very important issue for and a major concern for India also. And also I said it can affect agriculture. It can affect crop yield because it is affecting the radiation reaching the Earth's surface. It's called solar dimming. So, and also deposition of these aerosols on the leaves. If you see during summer season when you have a lot of pollution, maybe you may not experience here, but you go to Mysore and all, you may see lot of dust is covered on the leaves. It can affect the crop yield. So studies show that 1 degree centigrade in temperature increase can lead to reduction of yields of many crops by 15 to 17%. And there will be at least 20% decline in the yield of major crops by 2050. So it can affect the agriculture. And if you see the newspaper reports, from 92 you can see a lot of news report about when the aerosols start getting attention. So you can see that a lot of news reports are there. And why we are specifically concerned in India is because We have a lot of observations in our country. This is an example of various observatories maintained by Indian Space Research Organization. So this is black carbon. As I said, black carbon is one of the most important aerosol species because it can absorb and contribute to the warming of the atmosphere. So this is from 33 sites across the country. You can see that it is going increasing from 1980s to 2010, 2020. So if this is going like this, by 2048, it will reach exponentially high. So it can cause a very significant solar dimming, and almost 5% per annum. If you convert this into PM, our particulate matter concentration, acceptable PM 2.5 concentration, that is particulate matter which is equal or less than 2.5 micrometer in size, is 60 microgram per meter cube in the atmosphere. That is acceptable, which is safe for humans. And this shows that if you convert it into PM 2.5, it is much more than that. And another thing is glaciers, Himalayan glaciers. There are so many reports that black carbon deposit on Himalayan ice threatens Earth's third pole, and 90% of Himalayan glacier melting is caused by aerosols and black carbon. Like this, you can see a lot of news in the various articles and news report. And as I said, we have so many observatories for measuring these black carbon aerosols. But one important thing which we observed recently is that black carbon is not only present at the surface, which is affecting the health, but it is also present in very high levels in the atmosphere. That is because of a different reason. That also I want to inform you. See, up to 3 kilometers we can study black carbon using the aircraft of Indian Space Research Organization. They have a research aircraft. We used it many times and we studied up to 3 kilometers. Above that, since it is an unpressurized aircraft, we cannot go higher than that. So only way is using a high altitude balloon facility, that is TAFR as a facility for high altitude balloon experiments in Hyderabad. So we used this facility, and you can see that the black carbon is comparable to that of Bangalore at around 8 to 10 kilometer altitude. You can see where I am showing the pointer. See, below you see it is about 2 to 4 microgram per meter cube. But secondary, there is a very big layer of black carbon at that level. So we wanted to study that, and we wanted to conduct so many balloon experiments. This is an example of one experiment we conducted recently in TAFR facility. So this balloon can take the payload up to hundreds of kilograms weight. Our instrument, it can take up to an altitude of 20 to 25 kilometer high. And this is launched from Hyderabad TAFR high altitude balloon facility, early morning hours. So you can see that this is how we make measurements at higher levels, and we found that consistently, it is not one time, so many experiments we conducted, we found that there is a huge layer of black carbon aerosols at the altitude of about 8 to 10 kilometer, and there is no sources at that time. You know that all the human-made sources of black carbon aerosol is close to the Earth's surface, and it was very surprising to us why such a high altitude this kind of aerosols present. So you can guess why 8 to 10 kilometer this can be there. It can be air traffic. Another, like automobile we are talking about. Not many studies are there on the emission from aircrafts, that is our airplanes, passenger or other airplanes. So this is a video from, you can see in Zurich School of Applied Sciences. You can see this video in YouTube also. So you see every dot shown here is an aircraft flying in the sky. So it's showing 24 hours of aircraft movement in the sky. As I said, we started using the aircraft of ISRO in 2006 onwards. And we were under the impression that, it is not like a traffic block on the road. So we thought sky is all free. We can take our aircraft to any place, location and do our experiment, because we needed to follow sometime air trajectory. If an air parcel is moving from one place to another, we have to track that. We have to tell the pilots to, take the aircraft to that parcel, you follow. Then what we used to hear is that, no, we cannot go there, another aircraft is flying there. So it was very difficult to fly aircraft wherever we wanted, because other aircrafts were flying at that altitude. So in sky also it is, traffic is not very small. So you can see from here also, most of the sky is filled with aircrafts. So whatever you see illuminated area is daytime there, you see much more aircrafts. Now in US it may be daytime here. So a lot of aircrafts are flying. So this is because of air traffic. Aircrafts are emitting and we see that kind of thing there. So just to tell why we are worried about the aerosols or black carbon at that altitude, the reason is, if it is at the ground, it cannot go much higher levels because of clouds or other atmospheric processes. It will be washed down at some point, or gravity will pull it down. And these black carbon aerosols are porous. It is not very, easy to bring it down to the ground. So once it is emitted at 10 to 12 kilometer altitude, international flights are flying at 10 to 14 kilometer altitude. So it can sometimes go to stratospheric altitudes, and ozone layer is there. Our protective ozone layer is there. So some of our studies have shown that it can reach that altitude. It's possible. It is not that it's impossible. But then it will act as a neutral surface for ozone depleting reactions, chemical reactions. In that case, it is going to be another global issue. So this is the point I want to give you information. I want to convey you that this kind of emissions can cause some issues to human being. It's not only emissions which is happening close to the ground. So this is a very new area which we started studies only a couple of years back. So it will take some time to get very meaningful result. Now coming back to what if we don't act now, that is where your role comes. There is a concept climate science community says tipping points. What is tipping point? Climate will switch from one state to another, and that is irreversible. Just one example I will tell you. Arctic ice, if all Arctic ice collapse one day, assume that in a couple of days of time or 2 to 3 months time, entire Arctic ice is melt or collapse. This is called a tipping point then. So like that, there are so many tipping points which we define. If that happen, we cannot take all the water back to Arctic and make it as ice. It's an important part of climate system. And then sea level, how much sea level it can go up, you can guess. And that will be large amount of Earth's surface will be under water. So this is called a tipping point. It can happen tomorrow, or it can happen, it's like earthquake. Nobody can predict when it will happen. It can happen tomorrow or next year or 30 years, 20 years after. We don't know. So there is a term tipping point. If we don't act now, thinking that tipping point will not happen, that will be a problem. You know why? This is the simplest way I can tell you what is the problem. So there are two cases I am showing here. One is, one transition from one state to another. Forget about all climate or anything, you may not be familiar with that, but just to see this example, I am showing only two balls. So this ball is forcing, this is our climate system. If this is the case, then if you are forcing the ball like this, you pull it will go up little bit and come back to the original state. It won't be, so this is called a low risk transition for high resilience. But unfortunately, we are now here in this system. If we are not in this system, we are not in a stable system. So we are in a high risk of transition, low resilient. That is the summary of or the meaning of tipping point. So this is a much warmer world here we are talking about. If you push it little bit, we will fall here, and then it's irreversible. When I say it is not irreversible, capacity to recover is very low. You can't take the ball back to here, just like the example of Arctic ice I mentioned. So we are almost here. So we all have to work together and protect the planet. And that is the reason UNFCCC, United Nations Framework Convention on Climate Change, every year they meet, all 197 countries have participation in that. And see, 21 March 2019, the Executive Secretary of UNFCCC said climate action is more urgent than ever. This is a couple of years back. We are already in 2025. So this is very important. And as I said, Paris Agreement is one of the most important conference where all the countries, 195 nations, committed to limit the increase in global average temperature to well below 2 degrees Celsius. And this is what we are now. We are getting hotter and hotter. There is no indication of any reduction in emission. There are efforts definitely, but temperature is still going up. It's not stabilizing anywhere. So this is all I want to tell you. Before I close, I want to tell you, before also the speakers mentioned about it, how can we contribute as an individual? Because for carbon dioxide, even our nation cannot contribute much. We are contributing only 6 or 7% of global carbon dioxide emissions. So there are other countries contributing more. They all will have to cooperate. Then only the carbon dioxide issue can be solved. Black carbon aerosol can be solved to some extent because it is relatively a local issue. And we can contribute by doing a lot of things. See, air quality, for example. In one paper appeared in the Lancet journal, they say 2 Indians die every minute due to air pollution. And this report also says that air pollution and climate change are intricately linked and needed to be tackled together. We cannot address as 2 different issues. So as an individual, we can do is that switch off lights and fans when they are not in use solar heaters, walk short distances or use bicycle instead of using motor vehicle, transition to electric vehicle, plant trees, close taps after the use. A lot of things we can do, very, very simple thing in day-to-day life. And one last point I want to mention is what is for students, because students always ask me that, okay, we study climate change or contribute to climate change. What is the future prospect? So this is what the future prospect. Climate change is an interdisciplinary subject. Every field is needed. As I said, it's an interdisciplinary topic. And economics, politics, statistics, mathematics, electronics, medical sciences, aerospace engineering, everything is needed to be together if we want to address any climate change issue, mitigation or adaptation or planning, anything to plan, we need all this. Any engineering or science degree at graduate level is suitable for coming to climate change studies. I'm a physicist, basically. I'm a master's in physics, but I changed it to PhD in climate science. And I continued my career in that. In our Center for Atmospheric and Oceanic Sciences, there are mechanical engineers, there are physicists, there are so many others. So climate change, all field people, aerospace engineering, civil engineering, mechanical engineering, doctors like Dr. Paramesh, we are all together to address this issue. So you have a lot of job opportunities in this field in the coming years because it's one of the most important problems. For example, economics is required to assess economic viability of a mitigation strategy. If a government want to make a policy decision on a mitigation strategy, we need an economics expert. A medical doctor is essential to study the impact of air pollution on health, like that. And India is committed to significantly reduce the emissions intensity by 2030. So electric vehicles and use of renewable energy all will have importance. And one thing I can tell you is that 30 years I'm in this field, as I said, 25 years I'm guiding PhD students, more than 25 years I'm supervising PhD students. And all my masters and PhD students in the past, they used to aspire for a government job or go abroad for higher studies. But now the scenario is different. Many students are joining industries. Their preference is also industries. Microsoft, Infosys, Wipro, so many companies they prefer to go. They get involved in topic like weather prediction, for example, prediction of weather, or event management. Event management companies want to know what will be the weather after a week. And carbon budgeting and crediting, if a company is emitting lot of carbon, they have to pay. So they have to take carbon credit also. All these need people. So two areas which where not much initial investment is needed if you want to start a startup company: carbon budgeting and weather prediction. You need a laptop or desktop to do that. And electric vehicles, development of solar cells and storage devices, development of hybrid solar wind energy systems. Daytime you have solar energy, but night you don't have solar energy, but you have wind energy. If you combine the two, you don't need storage systems, or you can have advanced storage system for storing the energy received during daytime or nighttime. So manpower requirement for climate change and related research and development work is quite high in the near future. That is what I want to convey you. So I am closing the brief talk. And the summary is that crucial questions to be answered to tackle climate change are so many compared to what is known as of now. So a lot of research is needed. And as we study the climate problem more and attempt to answer crucial question, it appears that the picture gets even more complex and challenging. So I have listed a few questions which are unknown. Like that I can put several tons of questions like this. So thank you all the best.
Dr. H. Parmesh, he's an expert in the area of health. So he's expert in health issues related to climate change. He'll be talking on that, climate change and health.
Hello. So, respected M. Rajiv in his absence, Mr. Matthew John, Mr. D. Venkata Someshwar Rao, Professor S.K. Satish, distinguished faculty members, my dear students, future with you only, what you are going to learn, you are going to take us forward. This thing I like to give a talk. What is the impact of the environmental pollution, climate change on the planet and on health? And I'll be greetings from my institute, Indian. And this is the building, 116-year-old building. Now, the role of environment, planet, and what is its impact on the human health. Our planet, as you know, is a 4,600 million old. The environment is the mix of living elements having the impact on the human health by way of supplying all the resources for us. Secondly, to assimilate the waste what we generate. Thirdly, which helps in sustenance of life for good health and for the existence of life as well. Climate change has an impact on our environment. How it is, we'll find out about it. There are various driving forces and global environmental changes. The driving forces such as excessive population growth, upsurge of the rapid urbanization, new industrialization, rapid globalization, pervasive poverty and inequity, non-sustainable consumption, transboundary chemical transport. The global environmental chances are air pollution, global warming, climate change. They're all interrelated, as Professor Satish just mentioned about it. The ozone depletion, 10 kilometers above us in the stratosphere, it is important where we have the variation. And also, at the troposphere is extremely irritant. 10 kilometers protective to us at ground level is extremely irritant. And also it has got a cumulative effect. Deforestation and desertification, forest fires, loss of biodiversity, increased use of biotechnology. All these contribute environmental degradation. And who is the suffering most? It is our children who are disproportionately vulnerable for suffering most of the effects just now and in the future. We have to tackle the issues. I already mentioned about pollution, global climate change. I think human beings, nature created so many species. We belong to only 0.01%. We damage, our greed in us damage the Panchabhutas, what we call 5 elements. We have Vayu, Agni, and Prithvi. And global warming causes the elevation of sea level and all the things we just heard about it. This has got an impact, all these 5 elements, what we deranged, have got an impact directly on our health, indirectly to the agriculture, the quantity and the quality, and water resources in supplying water, water quality, competition for the water going to increase. We are already Kaveri water got a fight between Tamil Nadu, Karnataka, and Kerala for one river. And coastal erosion causes additional cost, and species of natural areas demolition and cryosphere diminishing glaciers causing a lot of problem for us. Now, what are the impact has got on the climate? This is based on the planet. This is based on the IPCC report, 6th IPCC report. The extinction of species 1,000 times higher. Earlier, only one species, over million species, per in 1 year it will extinct. Now thousands of them per year is extinction. Now marine heat wave is 34% more frequent and 17% longer since 1925. The extended 5 season doubled and potentially burnable areas has increased. Amazon rainforest basin transformed into grassland 4 times more. The wildfire in Arctic tundra increases 9 times in 1996 to 2015. 54% of the land and sea species extinction has been appreciated in this century, going to appreciate in this century. Further, 59% loss of green turtles, 75% reduction of the freshwater fishes by 2075. 15% loss of permafrost by 2100, which release up to 67 billion tons of carbon, further increase the global warming, climate change, and 33 new germs, ancient germs, will be coming into the picture. We have to prepare for endemic, pandemic. Health sector has to get ready for that one. 70 to 90% of death are coral reefs, 25% reduction of the summer sea ice, 2 square kilometers since 1970s. Our ecosystem near or beyond their ability to adapt. Having said that, let's see what's happened in the human health. This is the study WHO 2017 published about it, and various countries, India the first in the line, China and other things. Nearly air pollution kills 6.5 million people every single year. In India, what causing the environmental change? 70% is from the air pollution. 20% is from water. 10% from the soil, pesticide, various others, the chemicals, various things. And 70% of the disease caused by the environmental pollution are non-communicable diseases. 70% of those non-communicable diseases are from the air pollution. And nearly in Asia, 24,60,000 premature death occurs every single year. WHO said only two pollutants we worry about it, 2.5 micron size particle, and other one is the tobacco smoke. At that time I said, I think my country, I have to consider the ozone. I included ozone in that one. As we go along, we appreciate that, why I make that statement. So the basic necessity of sustenance of life. Sustenance of life, the word started from the year 2015 up to 2030. It is started by in WHO, my dear friend Rudiger Kresch. We meet quite often. He started that one. From 2015 was social discipline in health. This is what he started. So among the 17 items he mentioned, 3 are the more important for us. One is the water, other is air, water, food. You cannot live without breathing more than 3 minutes. You cannot live without taking a drop of water more than 3 days. You cannot live without taking a grain of food more than 3 weeks. These 3 important you have to remember. However, we have to convince the policymaker the economic burden of all those things. They always look for those things. What is it? Welfare losses from the environmental pollution is US $4.6 trillion per year, nearly 6.4 of the global economy. There is wide scientific consensus that climate change is a reality and defining issue for this 21st century. Having said that, let's move. Air pollution is an invisible killer. Nearly 43% of the chronic lung problems is from air pollution. 29% of the lung cancer is increasing more and more from air pollution. 25% of the heart disease, cardiovascular disease. Nowadays, youngsters getting more heart attack than what used to be earlier is from the air pollution. 24% of the stroke is related to air pollution. It has got an impact from womb to tomb. Why it is, I'm going to tell little later on. So when you talk about the air quality, air is the mixture of many gases, moisture, like aerosol I mentioned about it, and some inert materials. Nature has a self-purification process. The imbalance in the process causes the ill health. We cannot find, nearly 99.6%, they say 100%, we cannot find a clean air anywhere in the world. And what we need in the air, what we breathe, nitrogen is 80%, oxygen nearly 20%, and carbon dioxide, what you worried about global warming, what we breathe is only 0.04%. But various other chemicals is there. When you say air quality index, these are all the items we measure in India. Suspended particulate matter 10 and 2.5 micron, sulfur dioxide, nitrogen dioxide, carbon monoxide, ozone, ammonia, and lead. We measure these 2 things. Americans don't measure ammonia and lead. Now, when you talk about pollution, you should say, what is the size of the particle? If it is a gas, is it water soluble or not? Why it is important is to tell which part of our system is going to be affected. Bigger molecule, more than 10 micron, pollens and all this in 25 to 30 micron, big molecules. More than 10 micron, and also a gas which is water soluble, like sulfur dioxide, aldehyde, and all this thing. They impact upper respiratory tract from nose to thoracic inlet. So you have the nose problem, eye problem, pharyngitis, laryngitis, whole lot of things will come there. And less than 10 micron, up to 2.5 micron, the lower respiratory from here to the alveolar levels. It affects, you have got trachea, bronchi, bronchioles, alveoli. These are all the inflammation, allergy starts that. Yes, and also that is the medium dissolving molecule is ozone. That will affect the lower airway. The small particle less than 0.2 micron, it will cross the 7 layers of the lung, enter the bloodstream. Where the epithelium of blood vessel is there, small platelet aggregate, small particle, they will distribute all over the body, damage all over the body, all the vital organs. We have enough data. That has been proved by the radioisotope study inhaling various particles. The major brunt from air pollution taken by the lungs, upper respiratory, lower respiratory tract, and it will travel all over the body, damage everything. But the plastic, I'm really happy to see glass bottles. There is no plastic bottle here. I'm very proud of that one. Why? Recent study has come, January. The American study, one of the brand plastic bottle they've taken, 1 liter bottle, they found out 240,000 suspended particulate in that bottle. 96% of them less than 1 micron. They'll enter the bloodstream, enter the brain, whole lot of things it will damage. This is what I'm really proud to see. Tamil Nadu, thanks, and the institute not having the plastic, I'm very proud. Thank you very much. Further, what we talk about carbon, what we breathe, the carbon dioxide 0.04%, but these are greenhouse gases. The most common thing, greenhouse gases producing air pollution, dioxide. Earlier, carbon dioxide production was there. Global warming was there. That's mainly from the respiration of the animals and people and vegetables and volcanic eruptions, decomposes in the natural waste, burning forest once in a while. In addition to that, we are adding now, today, deforestation for industrialization, cement jungle coming up, rapid building and all this thing, automobile emission, bigger thing, non-vegetarian population becoming more and more, they produce all this thing. And earlier the carbon dioxide, global was, 1,000 years ago, it is 280 part per million. It steadily came down. In the mid of 1800, middle of 1800, industrialization started. That's when the carbon dioxide started shooting up. Now, as of March 2022, according to NASA, we have carbon particulate matter is 470 part per million. What did it cost? So, carbon dioxide, 84% global greenhouse gases is carbon dioxide. Methane, 9%. Nitrous oxide, 5%. Fluorinated gas, 2%. The lifespan of the adversity of the greenhouse gases is carbon dioxide takes 80% takes 20 to 200 years to biologically dissolve completely. 20% carbon takes about 1,000 years. Methane takes about 12 years. Nitrogen dioxide takes about 114 years. Ozone and water vapors do contribute, but they're very short-lived. However, the particle methane and nitrous are fluorinated, they are the most dangerous, most potent, as a matter of fact. And we produce 3 times more carbon dioxide than the Mother Earth can able to manage. Having said that, now we are at a stage of our living is at stake. Why? If you look at the 3 degrees of climate destabilization, Satish mentioned about it. Now we are at the edge of 450 part per million carbon dioxide. With this one, our temperature going to 1.2 to 2.7 degrees centigrade. We are at this border. If we lead further, carbon dioxide goes up to 600 part million, up to 600, irreversible damage going to occur. If it is more than 600 part million, then this is going to live in this world. Maybe cockroaches might live, I don't know. Atomic work, they survived it. Nothing going to live. This is a fact. It is a time to act. And we, as I said, Mother Earth can manage about 3 billion tons per year. We produce 9 billion tons. Maintain the carbon dioxide 250 part per million to 1.5 degrees centigrade by end of century. It is not possible. At least we aim for 2 degrees centigrade. So now, where do we get the energy? We eat food and we drink water. So we take food about 1 to 2 kg per day, water 2 to 3 liters per day. What is the energy we get from that? It's only 10%. 90% comes from the oxygen. How much oxygen we need? Resting person or bedridden needs about 500 liters of oxygen per day. Active people like you need 1,000 liters per day. Sports people, you're all sports people, you need 1,500 liters per day. To get this oxygen, we have to breathe 10,000 liters of air in and out, and heart has to pump 10,000 liters of blood to carry the oxygen. So you all have cars, isn't it? Yes or no? Yes. Do you need oxygen? Yes or no? You are all good at it. Yes, you need oxygen. Excellent. Many times they say, no, so it goes in petrol and all that, but that need to combustion, oxygen you need. So, 1 liter of petrol needs 1,700 liters of oxygen with consumption of a liter to move about 10 kilometers. So, how much it costs? What is the oxygen cost? 1 liter cost Amazon, 30 rupees. So active people like that, 1,000 liters, how much you need oxygen? I'm not good at mathematics, I'm a biology. Physics, mathematics doesn't enter my head. I'm a biologist. That's why I took medicine. 30 rupees, 1,000 liters, 30,000 rupees. You need 30,000 rupees oxygen, nature is provided. Your car to move 10 kilometers, you need about 50,000 rupees. Nearly 1 lakh rupees nature is providing us. We are destroying it with our greediness. Now, let's look at the other air pollution, allergic airway diseases. I think this is a study we have done, published recently. 1994, in a common population, pediatric under 18 years, allergic rhinitis is sneezing, doing that kind of habitat. Nobody is doing, you're all coughing. I'll come to that part later on. All of you are coughing here. Most, I heard about it. I'll talk about when cough comes. Now, 1994, 22% has gone up to 50% in 2022. And the allergic children, it was 75%. Now it has gone up to 2022. 100% have allergic nose with asthma, allergic rhinitis combination with middle ear. And also it has got comorbidities. Common pediatric population, middle ear infection is over 9%. And in allergic children is 22.5%. That's the most common cause for the deafness in children. Further to the sinusitis, average population is 1%. But in allergic rhinitis children is almost nearly 35% of sinusitis. But coming to the lower respiratory tract, asthma, we have been doing from 1979. In Bangalore, it was 9% of the children, 18 years, had asthma. In 20 years, study has gone up to 29.5%. Every year is going up and up. That we correlated to the change in demographicity of Bangalore, increased number of automobile industries overall. We correlated that, hypothesized. But 5 years later, it comes from 29%, it comes to 26%. We all worried about it. That's why we met all the WHO. I'm one of the invited people. We met in Perth, Australia, all the lung experts. We met why it is coming down. They said because people are there already, they have been saturated. You don't see any further. Maybe persistent asthma may be more. Persistent severe asthma might be more. Yes, that's further to that one. I think next year, other 5 years later, 29%. And ICMR said 2014, so 26%. And 2016, GAN study, global asthma study, in Kerala it has been done by my friend, dear friend. He was my student also. So Professor Sukumaran. And he shows about 28%. Now, true to that one, the persistent severe asthma, where they need constant medication to control, is gone up to 20% to 72%. And persistent severe asthma, where the continuous medication, they visit emergency department, hospitalization more often, is not been very well controlled. That has gone up to 4% to 11%. And having said that, let's move further. And prevalence of chronic cough. I made a cough module. So cough module, about 10 variety of cough I can mimic. I think you're all coughing here. Hearing that cough, only 1%. Oh yeah, yes. I've been observing in this one. So I think this is upper respiratory cough, nearly 60%. In that one, 10% had the pharyngeal-laryngeal cough, this side. This side. And also most of them cough, other 40% is from the bronchial cough. They got allergic asthma related cough. Yes, I heard it. So, all right. You cough, nature has provided. What is the speed of the cough? Air will come there. 750 kilometers per hour. When you cough, and also you produce about 1,000 droplets, aerosol. It is going to spread a lot. It is an infective cough. Nobody going to suffer from this. It's an allergic cough. No, so they are all fever and all this thing. It's an allergic cough. It comes with a speed of 750 kilometers. When you sneeze, what speed it will come? 1,250 kilometers per hour air speed. Nearly 1 lakh particulate matter will come there. So when you're coughing anything, you cough like this. This is the best way of coughing. So you don't spread anything like that. Okay, having said that one, let's see. In Bangalore, coughing more than 2 weeks. But this is the cough disturbs the sleep. That's what is the persistent cough. Your cough is not going to disturb your sleep in the night. You're all sleeping all right, I know for sure. In 99, in Bangalore, 8% of the children used to cough more than 2 weeks, and they used to disturb their sleep at night time. It's steadily gone up. In 2017, 21.25% gone up. That's related to air pollution. And every year is a 0.5% increase. This cough, working mother, even for 2 weeks cough, there are 20 consultants has been seen in Australia. This is why economically burdened working parents are worried about. They want instant stoppage. It will not. Normally you have to cough. How many times you can cough? God has given 10 to 15 times you can cough. That is not a cough you worry about. Maximum up to 34 times you can cough. But it doesn't disturb your sleep. But what are the comorbidities? Comorbidities of the cough causing the more of burden, socio-economic burden, and morbidity is much higher, and mortality. So now, how many people are snoring? We did a study. Parents come for a well baby checkup. We ask the question, does your child snore? Sir, why are you asking for that? No, I want to find out. Normally, people snore. How many people will snore? 8% of the children are, that is called sleep disorder breathing. 8% children snore. In that, 1.04% are the sleep apnea syndrome. Obstructive sleep apnea syndrome. What is sleep apnea syndrome? I mean, so what happens? Breathing at night time. This is what it is. This is sleep apnea syndrome. What is the, you take breathing, suddenly you stop. Chest is moving, air is not coming out. During that time, you build up the carbon dioxide, oxygen will come down. So that's why what business people have come. Most of the hospital is committed politician now, medical colleges. They want to enlighten that. Sleep disorder breathing. Go 15,000 rupees they give. Sleep at night time. They measure how oxygen come down. Carbon dioxide goes up. They charge 15 to 20,000 rupees per sleep study. But anyway, if you have this kind of problem, your doctor will find out what it is. He will guide whenever needed. Investigation is needed. And so, sleep disorder breathing in chronic cough children is nearly 27%. Average is 1%, 27%. In them, nearly snoring, 42% at night time, 43% mouth breathing, rubbing of the eyes, 27%, grinding the teeth at night time is only 17%. 3.2% of the produces laryngeal dyskinesia. Whatever while you're breathing, voice box should open, but suddenly it closes it. You become panicky. You do like so that many people think of asthma they treat it, but this is one thing we have to train our doctor also. So what you do at that time, when you get a breathing, you pant like a dog. You do like that. It will get better itself. So this is what we have to train our doctors also, identify that one. Now, outdoor air pollution talk. Children of heavy traffic school areas suffer more from asthma. It further increases the low socioeconomic power. This is a study we have published in 2002, about 20,000 children. Now then, to prove the outdoor air pollution, we took a study, 4-year study. We did traffic police in Bangalore, traffic police officer, about 1,045 traffic, 1,000 non-traffic police officer. In traffic police suffer the most asthma, chronic cough, shortness of breath, running nose, wheezing, urticaria, fever. So double the number of traffic police suffer from the air pollution. Do you have substantial input? I think based on this study discussed in the parliament, face mask came from our study from the traffic police officer. 2015, they changed it to better quality. And during Diwali times, what happens, lot of asthmatic children visiting the emergency department, apart from burn and all this thing, visiting. So 100% increase of the asthmatic visiting emergency rate was there. At that time, why it is, we want to find out. So pollution control Karnataka didn't measure the pollution level. My friend in Pune, he measured pollution level at that time, Sandeep Salvi. We found out 200 times more of sulfur dioxide during 2 days. Sulfur dioxide, water-soluble gas, immediately affects the respiratory tract. That is what we proved it. And this study was taken by Supreme Court judgment. And 31st of March, they not to burst the crackers at silent zones. And educate the society. Total ban of the coloring matter. Coloring matter is much worse one. They did it. And bursting of the firecracker should not be decibel, more than 110 decibel. And it should be 10 feet away from that. And Supreme Court judgment 2018, bursting of the crackers in between 8 to 10 p.m. during Diwali times, and during Christmas time and New Year's Eve, but 2 hours, 12 to 2 a.m. And increased temperature in summer season has shown increase in asthma. I was talking ozone. I think there is definitely increase. In 1994, asthma 2.8%. In 2009, it got 28.5%. That is almost in 15-year period. That's mainly attributed, is mainly from the summertime, bright sunlight is there. Automobile emission and low wind velocity, ozone production is more. That is in troposphere. We have higher ozone content. That has produced from 2% to 28%. So as I said, ozone is a cumulative pollutant. Only 2 pollutants were cumulative. One is the ozone, other one is the sound. I'll tell later on. Now, I did mention about ozone we have to consider in WHO. Our country, we have to think differently along with that one. So I think mortality from ozone increased by 46% from 2000 to 2000, published in the 2023 by Lancet. So that's a 2017, I said, ozone we have to take into consideration. We have this data, so it has been proved now. Now, let's come to the indoor air pollution. So indoor air pollution, these are the one. Dust mites. Dust mites is found out in first time in India, Agriculture University in Bangalore. 50% allergy and asthma come from the dust mite. So I think second one is the cockroaches. 25% allergy come from the cockroaches. And pollens, 7.5%. Fungi, 7.5%. Pets, I think in 1979, Bangalore, we had 4.25%. In 2005, 5.4%. But they are not the cause of increased prevalence of asthma. We are substantiating data. Where the pets are high, allergy is less. In 2018, GINA guideline, Global Initiative Asthma, they said, if you want less allergy and asthma, have 2 pets in your house. You take care of them. So we have enough data to substantiate that one. And viral infection, less than 5-year-old children, respiratory viral infection will be there. That is the most common cause. And tobacco smoke in 1994, triggered by asthma, by parents smoking 6%, 2004 it got 7.9%. Mosquito coil burning is gone up from 5%, 7.9%, and 2010. So these are all the contributing factors. Now, indoor air pollution. Nearly 0.2 billion people only use the cooking fuel. So we have to use other fuels. I think electricity is the best. If you have electricity using, the prevalence of asthma in that house is only 1.2%. If you use the cooking gas, 2.6%. Kerosene, if you use, 8.3%. But non-commercial cooking fuel, like cow dung cakes, agriculture waste, firewood, nearly 48% of the people, they've got asthma, indoor air pollution. However, the green prime minister gas improved. Now the data has shown, ICMR data shows, indoor air pollution in India has come down to 60%. Outdoor air pollution has increased to 115%. So now, indoor air tobacco smoke is very important. The WHO says you first phase of tobacco smoke and 2.5 micron. I think we did a study. I think threefold increase in the asthma in a home with a tobacco smoke. A single parent smokes in that one. If you ask the question, does your husband smoke anything? No. He smokes outside. But his clothes, everything will bring some smell and everything. That is a contributing factor. They won't give up their husband. They're lucky to have the wife. They're like that. And we did a study how to take care of tobacco smoke, banning this one. We used to go, that country says this, we didn't have a data. We spent 7.5 years collecting that data. In school children, nearly 3,078 children, between the age group of 10 to 17, 41% of the urban school children going are smokers. The first cigarette smoke, they had it. And rural children, 2,194 children we did it, between 10 to 17 years, 21.8% rural children are the smokers. After 18 years, rural children take over from the urban children. Why this is? We have to find out, educate the parents and also the adolescent individually when they come to the doctor's office. What made them to start smoking? 29% said peer pressure. Hey, sissy, chalare, smoke. What will happen? Nothing will happen. Smoke. This is what it is. This is the most common cause. We have to educate the children. Curiosity, 18%. Pleasure and fashion, 16%. Frustration, 12%. Status symbol, 10%. Relieve tension, 8%. Concentration, 5%. Other reasons, 2%. These are all 700-year data, and ill effect of that one we presented through our chief secretary, our MLA in our area, J. Alexander. Alexander was the chief secretary, minister also. Through him to our chief minister, I take care of his grandchild also, S.M. Krishna. On the same day, he announced we will ban tobacco smoke in Karnataka. Karnataka, the first state in 2001, banned the tobacco smoke. Afterwards, Supreme Court judgment came, 2003, all over India, banned the tobacco smoke. I, being the president of the Century Club, started by Bharatana Sir Vishwesharaya, I banned the tobacco smoke first in 1997. First social club in the world where the tobacco was smoking is banned in that one. We have a chimney bar. People want to go, they can smoke there, not anywhere in the club. Now, I think e-vaping became more prominent. I want all of you to please listen to that. It is as bad as tobacco smoke. And these are various cigarette varieties swimming there. And this e-cigarette produces acute parenchymal lung injury and also increases chronic obstructive pulmonary disease, increase asthma severity. And also many people have the habit of smoking to get high. We use volatile solvent, dry cleaning fluid, paint thinner, aerosol solvents, air freshener, keyboard cleaner, gases, ether, halogen, alkylated locker room deodorizer. Look at the lung, natural lung and smoker's lung, how it looks like. I think it is a must. We have to, as bad as smoking, we have to ban it. And our cigarette butts, nearly 24.5% of the ocean debris is a cigarette butts. You smoke, throw it like that. After rain, it goes to drains, lakes, rivers, and it goes to 24% are related to smoke. The cigarette butts have got 169 chemicals in it. They are most dangerous too. And coming to the after lung and respiratory tract, we'll go to air pollution, produce non-pulmonary disease like coagulopathy. Coagulopathy I mentioned about when the small particle less than 0.2 micron crosses the blood lung layer, reaches the blood vessels. Their platelet cut, and it travels all over, damages every organ. In addition to the mother carrying the baby, it will deposit on the placenta. That decreases the nutrition of the baby. So depending on severe, stillbirth can happen, and small and premature babies can happen. Higher number of premature babies happening now. And small for date, even a mother carried 9 months, baby is only 1.2, 1.8 kg. But these children who are born with a small airway caliber, they are born with narrowed windpipes. They are more prone for repeated wheezing, repeated asthma. Later on, respiratory they are going to happen. This one, we have to educate the parents in this context. I think that's what we used to say. Mother has to be, her environment has to be, her mind has to be free, everything. We used to do Taurmane Hogtare anta helidare Kannadadalli. Used to go to mother's house. Her beck and corner, anybody is there to help her out. So these are all the very essential things we have to educate. Oh, sorry. Now it produces increased cardiovascular disease, cancer, diabetes, obesity, baldness, and chronic liver disease, liver cancer, chronic kidney disease, all been reported from this one. Next, air pollution impact on central nervous system, autism, dementia, Alzheimer's disease, cognitive performance, and loss of smell, anosmia, and neurodegenerative disease has been identified. We have enough proof to substantiate that. And recently it has come there about July, about 2 weeks ago, 3 weeks ago. Outdoor air pollution, dementia, evaluation, about 32 studies have been analyzed, where 15,690 patient records have been analyzed. The outdoor air pollutions are risk factors for dementia, indicating that reduced exposure to pollution could reduce the dementia, and stricter air quality standards would likely to provide substantial health, social, and economic benefits. Now, behavior problem. When the air pollution is very high in the town, the crime rate has increased. It has been proved beyond that. And impaired judgment in the heavy courtroom with a polluted, too much crowd, judge also can give a wrong mistake. It never used to happen. In old villages, we used to have early katte. What is that? People tree. Early katte is the best tree, because it gives, that's the only tree give oxygen 24 hours around the clock. So judgment, memory loss will not be there in judges. That's why in a panchayat, they have to give it. That's what you have to remember, all those things. And also the long strike, when the wind blows, like soft music, it used to come there. People who go there because 24 hours, they used to sleep very well. We used to call those are all lazy bumps. Lazy chart, we used to call them. Now, and also worst test scores in a polluted area. If you take an exam in a polluted atmosphere, this whole air has to be changed 6 times per hour. If you don't change, ill polluted, it's a polluted atmosphere. If you take the exam, your score will 10% less. The same exam in a ventilated house, it will be 10% more. The parents might go, because you are given an exam in polluted, my daughter is to get 100, we have to take consideration in future. And immune suppression is going to happen. Depression, decrease intellectual quotient, increase anxiety has been appreciated. And also, Indian cities rank very high in the noise pollution. It has an impact, high frequency deafness in newborns, prematurity, intra-aortic growth failure, sleep disturbance, annoyance, headache, decreased work efficiency, poor school performance. This is as a chairman of the World Bank project, Karnataka State of Environment in 2003, we published Air, Water, Soil, Sound Pollution. It's only a book. Nobody wants to care for it. Anyway, that's a different story, but we have to pursue our work. One day it will take into action. Our measures to mitigate air pollution, global or climate change, the quality education of all the stakeholders, we have to do it. There are 8 stakeholders. We have to activate them. And also we have to reduce the pollutant at source. So greenhouse gases and all those things. And also reduce the population growth is very important so that demand becomes less. And also we have to protect the affected people who are already affected. Research based on our values. We have to think locally, act locally, propagate globally our results. Whenever needed, legal activism we can take. Our black coat friends join with the white coat friend to help the society. Now, this is another only about 3 minutes. What we can do ourselves. Government doing its own way, international doing go to United Nations doing its own way, and each government doing its own way. So we have to reduce carbon footprint 2 tons per person per year. America produces 6 tons per person per year. Global average 4 tons per person per year. India 1.15 tons per person. Still we agreed. We had a part and parcel of the globe. We had to reduce 2 tons per person. I said we want to reduce carbon footprint by nearly 70% by 2050, 100% by 2075. To keep the temperature less than 2 degrees by the end of this century. So each one of us have to reduce 2 tons per person. How can we do that? You already heard some of the people talking about it. If you don't have any car, you can save 2.4 tons per year carbon footprint. And if you have an electric car, you can save 1.95 tons per year. And if you flight, produce a lot of carbon in a higher atmosphere, 8 kilometers above. And so it produces 9 kg per hour per person. This is what it produces. And if you avoid unnecessary travel and all this thing, you can save 1.68 tons per person. And I be one of them. From 1990 COVID period, for 4 years I didn't travel. Only last May, I traveled to Mexico and conducted a workshop on the global warming climate change. And also during my time, my granddaughter graduated. And she don't want to be a doctor. She wants to be an aeronautic engineer. She joined NASA. Last week only she joined it. So I think last month I went to Nairobi to address the Commonwealth countries, how important to maintain the greenery. We maintained about, if we maintain the greenery, 1 rupee is spent, you save 34 times health benefit, not 34%. 34% health benefit. They have enough data to substantiate that one. And renewable energy, I think Satish has mentioned about, if we use the solar heat during daytime, wind at night time, we can produce enough energy to our country. These are the most important thing. If you do that one, we can save 1.68 tons per year. And public transport, if you use the bicycle and all this thing, you mentioned 0.98 tons per year. And reduce, reuse, repair, recycle. We Indians always been much higher than any other country, 70%. I think just because of a sale, you go and buy clothes here and there, whole lot of things, and hardly you use it in a year. Next year is a new pant cutter, that's throw away. That should not happen. As Americans, they do it. That electronics, clothes, other items cause carbon item, which raw material, manufacturing, transport contribute significantly. You need base purchase, yes, you do it. Repair what you can, recycle what you can. And also, refurbishment, renew of our houses, build our house based on Vedic mathematics. Vedic mathematics, what Vastu we call them. Vedic mathematics, it is what it tells for our country, good cross ventilation we need, good sunlight you need to kill the dust mite and whole lot of things, germs. Indoor plants are good. These are all the indoor plants, very essential, you can utilize in your house, and exposed to sunlight once a week. And diet, more plant-based diet with fiber and antioxidant, it is beneficial. So 1 kg of vegetarian food, it produces 1 kg of carbon dioxide footprint. 1 kg carbon. Non-vegetarian produces 5 to 35, 1 kg, 35 kg. So beef has the highest carbon producer. And food safety standard, Annual of India 2019, they mentioned about it. Have less food, less fat, less sugar, less salt in your diet, and 10% eat less than what you need. Don't waste the food. This is what we have to follow it up. And heat pumps, building account nearly 40% of carbon dioxide emission, and LED lights, it's a good. And long term, it's quite cheaper, good luminance, but make sure don't put the light to the trees and buildings, because nearly 956 million birds die every single year. These light affects the circadian cycle. Every animal, human have circadian cycle. When they're going there, they hit the windows, they die. 956 million birds die every year because of our. We should look at in that aspect. And also, LED bulb should not have the blue tinge. Blue tinge makes you awake. Red and yellow tinge, go to bed. Because good sleep is essential. Between some hormone is produced, melatonin in the brain. That produces the healing process. From any diseases or air pollution, whatever it is, healing starts from 9:30 p.m., 7:30 a.m. So good sleep, up to 4 to 6 hours sleep for elders, 8 hours sleep for youngsters. It's good sleep, it will happen. I think that we have to do that. So yellow light or red light in the night in the rooms. I think our guest house has a yellow light in the guest room, what we had. I observed all these things, thank you. Now, improving the equipment, use smaller appliance, pick proper pan, avoid excess frost, deep fry in the refrigerator, always clean quite often, and look for a blue flame. Yellow flame, which means the gas is burning inefficiently, blue flame is good. And that you can save carbon footprint 0.65 ton. Now, renewable base and all things. The villages, what happens, agriculture thing was there, cow was there. We used to produce methane gas. And so that you don't do the wood, the firewood and all this thing, that when the cow is alive, it gives milk, nutrition, milk product. Okay. And, so the cow dung can be utilized for the methane gas. Do we produce methane gas ourselves? Yes or no? I didn't hear you. I'm getting old, 86-year-old. Huh? Ah, okay, I heard it. Very good. So we can put a match when you're passing flatus. How many times you can pass flatus? In a day? Up to 15 times. Near 1.5 liter of methane you can produce on that. 7% is methane gas when you pass gas. It is non-smelling gas. And also the cow dung produces the energy, and leftover we can use organic manure. When cow dies, leather can be utilized. So that's why you call Mother Mata. Go Mata we call them in our country. Now, a healthy breath will always bring healthy life. Let each one teach one, plant one tree, and maintain it. It gives oxygen for 4 people, free of cost. And the last one, before ending, all of you go with a positive thinking. We can achieve if we start working today. Second thing, protect the Mother Earth at any cost. Third, pursue a research, the sustenance of life, think locally, act locally, propagate globally. Lastly, propagate your national ethos. We got one planet, one Earth, we got one family, and one future. Thank you very much for your patient hearing.
You're not allowed to upload.
Hmm?
You're not allowed to upload.
You said you will let Pradeep is there, he'll not go.
Thank you, Dr. Paramesh, for that engaging session. Since he spoke about health, which is something which we all could relate to, I could see that you were all directly engaged with that. And thank you for that presentation, sir. And before I call upon Professor J. Srinivasan for his lecture, I would like to mention one thing, that our headmaster would have had mentioned that this is all part of a wider NEP initiative across the nation, involving various national and international agencies to have strategic partnership with schools. Okay, so
Recording in progress.
The key person who is behind that initiative is Professor V.S. Jayagumar. He's there with us. So I did not announce his name in the morning. That is because we were focusing on the climate change part of it. So the NEP initiative, the whole framework under this event comes. He's the main person behind that. He's coordinating with national and international agencies, including ISRO, CSIR, IISc, and various other organizations, to bring them together to work with schools directly, so that students can get a direct linkage with the practical aspects of that. And Professor Srinivasan, so I had announced his credentials and everything in the morning in the inaugural session. He's one of the most distinguished scientists in the world in climate change. And he was the former chairman of, he was the chairman of Diveja Center for Climate Change, the founder chairman, I guess. Sir, I invite you for the presentation. Welcome, sir. Professor Srinivasan, I hope you heard what.
Yes.
Yes. Okay. Okay,
can
sir.
you hear me?
Pardon?
Can you hear me?
Yes. Yes, sir. We can hear you now.
Okay, now, I have sent the slideshow. Can it be uploaded there so that I can talk here?
Yes. Yes.
Let they upload, then no problem. Let's see. Here's the one, okay.
This one?
Hello, can you see the slide?
Sir, we are downloading your presentation, sir.
No. I uploaded. See whether you can see the slide. I've done the uploading.
Okay.
Yeah, we can see the slide.
Yes. Yes, sir.
Is the slide visible?
Visible, sir.
Yes, slide is
Yeah,
visible,
okay.
so you can move.
Okay, I can
change the
start.
slide.
Okay, good afternoon. We had a long session, so I'll try to keep this short. The main thing you must understand about climate change is that it is different from weather. All of you know about weather because weather is something is very important for you every day to decide what clothes to wear, whether to carry umbrella or not. So weather all of you are familiar with, but climate is not same as weather. Climate is concerned with long-term change in the statistics of the weather, okay? So You decide every day what to wear, depending on weather. You decide what clothes you will buy, depending on where you live. You live in Ooty, you need certain kind of clothes. If you live in Chennai, obviously you need a different set. So climate controls how you plan to do things, okay? Not day-to-day affair. Now, today we are concerned about climate change. Climate change is a very long-term change in climate, about which Professor Satish has already told you a lot, so I will not spend too much time on it. So weather is here. Next is climate variability, which is to do with year-to-year changes, this one. And finally, long-term change, 30, 40, 100 years is climate change. Now, all of you know that global mean temperature has increased rapidly over the last 20, 30 years, and it's attributed mainly to the increase in carbon dioxide. And to compare the temperature change in the last 100 years with the previous 2000 years, you see that Earth was slowly cooling during the last 2000 years, very slowly. But in the last 100 years, it's warming very rapidly, okay? So this is a cause of concern. This change in the slope of this curve is what is of concern, okay? Because of that, a lot of glaciers are melting both in the Himalayas, Arctic and the Antarctic, and that rate of melting is increasing from 100 gigatons to more than 400 gigatons, okay? And this will cause sea level rise, as mentioned by Professor Satish. The sea level rise is happening 5 times faster today than 100 years ago, okay? 5 times faster. So climate change is occurring because changes in ice cover, clouds, gases called greenhouse gases, and of course the reflectivity of the Earth's atmosphere and surface, okay? Now, these are global changes. In addition to global change, you also have a local change. The local change is caused by change in wind direction, change in land use pattern, urbanization, deforestation, and of course air pollution, which was discussed by Dr. Paramish. Now, the Earth's global mean temperature is a balance between what is absorbed and what is emitted, okay? What is absorbed depends on how much we reflect, ice cover, clouds, and so on. And what we lose to space depends on the gases in the atmosphere. If there are more amount of carbon dioxide, methane, and water vapor, they will not trap Earth radiation, okay? All of you know Earth radiates in a different wavelength than the sun. Sun emits peak value is around 0.5 micron, Earth is around 10 micron. And gases such as carbon dioxide, methane, and water vapor, they absorb in a region around 15 micron. So these are the gases which causes the increase in temperature of the last 100 years. But these are minor gases. The three major gases, nitrogen, oxygen, and argon, they constitute 99% of the Earth's atmosphere, but they don't have a direct effect on our climate because they don't absorb either sun's radiation or Earth's radiation. So you can see that this region here, around 15 micron, where the absorption is highest, while in the sun's radiation region, gases don't absorb much. Now, a lot of people think CO2 is a minor gas, so it cannot affect our climate. It's not true. If you look at the Earth's long history, the temperature of the Earth has been mainly controlled by carbon dioxide. It is the major gas which controls the Earth's climate. How do you know that? This is based on proxy evidence from the past. Remember, thermometer was invented only 300 years ago. Before that, we had no thermometer. So how do you know temperature? We are very smart. We use proxy evidence from other sources. For example, you can look at tree rings. The width of a tree ring depends on temperature. Higher the temperature, the ring is thicker, okay? Then you can look at ice cores through which you can estimate temperature. Then lake sediments, coral reefs, ocean sediments, all these give you evidence of what happened in the last 100 million years. Okay? Now, this was discovered by drilling into 4 kilometers of ice in Antarctica in a place called Lake Vostok. This drilling of this amazing ice core obtained from this drilling told us a lot about how Earth's climate changed in the past. This is how it changed. In the last 400,000 years, Earth passed through 1, 2, 3, 4 ice ages, okay, and a short warm period. We are in the latest warm period called the interglacial. Between 2 ice ages, you have interglacial, and this started around 10,000 years ago. And before that, there was no agriculture. During the ice age, agriculture was not possible. We were hunter-gatherers, okay? We lived in caves. Once it became warm, then agriculture was possible. And the last 10,000 years, our population increased from 1 million to 8 billion, okay? Now, if you look at the air trapped in the ice core and measure the amount of carbon dioxide and its temperature, you find they are closely connected. So in this graph of the last 400,000 years, temperature increase and carbon dioxide increase go together. This shows clearly that carbon dioxide is a gas which controls Earth's temperature, okay? Now, Earth's temperature is also controlled by the changes in the Earth orbit around the sun. Earth's orbit around the sun is not a circle, it's somewhat eccentric. And this eccentricity changes with time, okay? With a cycle of 100,000 years. Today, we know that Earth is inclined to the Sun-Earth plane by 22.5 degrees. But it has varied between 22.2 and 24.5, and that fluctuation in the inclination has a period of 40,000 years. The last part is where the Earth axis is pointing. Today, it is pointing towards North Pole, but 10,000 years ago, it was pointing towards the star Virgo. So all these things affect Earth's climate, okay? Now, among the gases which absorb Earth's radiation, water vapor is the most important gas. It traps more than 60% of the radiation. Next is carbon dioxide, then ozone and methane and nitrous oxide. Now, you might consider, if water vapor is so important, why is there no Paris Agreement on water vapor? Okay? The reason is simple. The amount of water vapor in the air is controlled by temperature. Okay? And that temperature is controlled by carbon dioxide. So carbon dioxide controls water vapor. Okay? So that is the thing which a lot of people do not fully appreciate. That although water vapor is an important greenhouse gas, the amount in the air depends upon temperature, which is controlled by carbon dioxide. Okay? So water vapor is an amplifier of climate change, not the main cause. Okay? Now, after global warming, the snow and ice start melting and temperature rises further. Okay? This is called the feedback. So this is the trigger. Initially, temperature increased due to carbon dioxide, then ice started melting. So when ice melts, you will see that the reflectivity of water is 10%, ice is 90%, okay? So whenever you melt ice, you are increasing the amount of radiation absorbed 10 times, okay? So that's what should worry us, okay? So if you graphically draw the amount of radiation emitted by the Earth by dotted line and radiation absorbed by the Earth by the solid line, you can solve this not using computer, but graphically. You see there are 3 intersections where the emission and absorption are equal. So there are 3 solutions to this equation. One is called the snowball Earth, which occurred 600 million years ago when Earth was completely covered with snow and ice. This one is the present climate, 50 degrees centigrade. And about 20,000 years ago, we had an ice age. Okay. So what you must know is, with the present amount of radiation coming in, Earth could have been in any of these three states. Why are we here? It's a matter of history. We started from here 6 million years ago, then carbon dioxide increased, and we shifted to ice ages. Then further changes in the Earth's geometry brought us to this temperature. So what you must remember is this: Earth's climate is not stable. It can shift between these three states if you perturb it sufficiently. Okay. So this was discussed by Satish. I will repeat that. We were in a glacial age 20,000 years ago, and due to perturbation caused by the Earth's geometry, we jumped to this state called the interglacial. Okay. So this happens rapidly. The Earth remains in a glacial age for 100,000 years. Then in about few thousand years, it goes from glacial to interglacial. So this is what you must know, that the Earth's climate is not stable, it can be unstable. You can see that in this graph, the mean temperature was low for a long time, 100,000 years. Then suddenly it jumped into the present period called the Holocene, the last 10,000 years. And I want you to see the difference in carbon dioxide concentration during the last 800,000 years. It was always below 300 parts per million. And all of a sudden, the last 100 years, it has shot up beyond 400 and will go to 600 and even higher in the next 100 years. So this is the point. Remember that Earth climate is not stable. It can oscillate between ice-free Earth, ice-covered Earth, and in-between conditions. Now, how do you know that? Geologists have looked at deposits in the ocean of rocks. The rocks are carried by the ocean into the, carried by river into the ocean, and where they are deposited. And when we look at this deposit, we see alternate layers. One layer, which is red in color, is low in iron, and the other layer contains a lot more iron. The layer with higher iron is when there was a lot more oxygen in the ocean. Okay, so from this geological evidence, we inferred that there was a period when ocean was covered with ice, there was no oxygen, and so we had what is called chert. Chert is a form of deposit containing silicon dioxide. So this kind of evidence is there in India. We go to Badami in Karnataka, you will see this, what is called banded iron formation, okay? Which tells us that the Earth's climate was changing a lot in the past. So summary is, we were in a completely ice-covered Earth 600 million years ago. Then carbon dioxide increased and we got into the last ice age 20,000 years ago. And then due to changes in sun Earth geometry, we jumped to the present climate, which suits human beings well. But unfortunately, we are increasing carbon dioxide, and there's a chance that we will go to completely ice-free Earth in the next 100 to 1,000 years, okay? So we can simulate this change using climate models. And in the model, if we don't change greenhouse gases or aerosols, which was mentioned by Professor Satish, temperature will not change. It will be around 14, 15 degrees centigrade. If you increase only carbon dioxide and methane and water vapor, it will go up rapidly, okay, till 200. But if you increase both greenhouse gases and aerosols, it is slightly lower. So aerosol is slightly reducing the impact of greenhouse gases. So the conclusion is the main cause for climate change is carbon dioxide globally, but locally, carbon dioxide is important, but also, as mentioned by Satish, changes in air pollution, changes in forest cover, deforestation, and increasing concrete in the urban areas, they all contribute to local climate change. Now, what you must remember is when climate change naturally, the change was about 1 degree in 1,000 years. Today, temperature is changing at the rate of 1 to 2 degrees per 100 years. It is 10 times faster, and that's going to make life difficult for us and for all living systems. An example of this is London, where we have the longest temperature record. This was the temperature distribution 60 years ago. Okay, 15.3 was the mean, and it went up to 17. Today, or around 2050, the highest temperature can be as high as 25 degrees centigrade. And so this red covered region, or orange, is where we have heat waves in London, because they are used to this temperature and they cannot handle this high temperature. Now, all of you must remember that India enjoys a savanna kind of climate. Most of India is a savanna. A few regions are tropical forests. But if there is a slight decrease in rainfall and an increase in temperature, we can become a desert. So we have to be careful that even a small change in temperature and a decrease in rainfall will cause India to become like Rajasthan. Now, other major concern is the ocean current. Oceans transport heat from the tropics to the poles. This is the way Earth maintains its temperature. Tropics gets more radiation, so it heats up rapidly. Polar regions don't get much heat, they are ice covered, but heat is transported. This red color shows transport along the surface to the Greenland, and there it sinks and comes back at a lower level, the blue line. So this so-called Atlantic Meridional Ocean circulation is a very important cycle which keeps Earth weather constant. But today, because ice is melting in Greenland, this circulation is slowing down. If it slows down completely, Indian monsoon will disappear. Okay, so that is a concern, that the slowing down this ocean circulation can transport our present climate to some climate in the future which is much, much warmer. And this change can occur fairly quickly, okay? This jump. Now let's summarize the main point. Is climate changing? Yes, it is changing. Are human beings responsible? Of course, they're responsible. Is climate change bad? Yes. Can we mitigate climate change? We can. If we make up our mind, we can do it. Now, what we have done in the last 100 years is, last 250 years, is Earth created coal, oil, and gas from forest and animals and other living beings, was converted to oil over 100 million years. In about last 250 years, we have burnt most of that oil. This is the reason why the CO2 is increasing so rapidly. Okay, so this is what you have to stop. Now, there's a way to do it, and there's a nice article in Scientific American. All of you can download that. It shows how we can get all our energy from wind, water, and sun. But we are not doing it. We are started doing it. In India, solar has started becoming important. But ideally, we should have done it in the next 5 years. But it may take more time. But this is possible. Okay. So we don't need oil, gas, and coal. Now, in 1990, IPCC published a report which said we should reduce CO2 emission. Most countries promised to do that, but in the last 35 years, only a few countries have actually made a commitment to decrease. Others are still not doing it, okay? Because of that, in the Arctic region, a lot of ice is collapsing rapidly, which is causing changes in climate, okay? Now, you must remember, we had COVID 5 years ago. COVID virus was a rapidly evolving threat to human life. Global warming is a slowly evolving threat to our existence. COVID, we were able to manage because we discovered a vaccine which enabled us to come out of the problem. But for controlling global warming, there is no vaccine. There is only one thing we can do is to change our lifestyle so that we do not emit as much carbon dioxide that we have done in the last 100 years. Okay. Now, this is the conclusion that Professor Somerville has made very nice when you, I, and all the people who are alive today have in our hands a thermostat, that is temperature control, that controls the climate of our children and grandchildren. If we do not act today, there is no future for our grandchildren. Okay, that's what you should know. And this is shown well by a cartoon in which the earth is shown as a ship which is going to go over a waterfall. That young girl is warning the old people who are ruling this world, all the countries, and the old people do not understand. So you young people have to get energized and make sure that the old people who control your life understand that there's a major threat that the earth will fall over this waterfall and life as we know it cannot exist. Okay? So climate change is a threat multiplier because it exasperates whatever is already there. Already we have problems, many problems. Climate change will make it worse. Okay? And the main cause, of course, is carbon dioxide, and others are also urbanization. And as already pointed out by Paramesh, CO2 is not the only problem. There is also issue to ozone hole, which is somewhat under control. Water quality is going down, air quality is going down, soil is degrading. So all these are connected to the way we are promoting economic growth. That has to change, and that change will come only when young people convince the rulers to change. Okay. Now, this is a short lecture. I was not able to cover every aspect. If any of you find this issue of great interest, please look at the NPTEL course in which I have given 30 lectures on climate change science. It's available on YouTube. So thank you very much for your attention.
Thank you very much, sir, for your presentation. That was a very engaging presentation. And on behalf of the entire audience, I thank you very much, sir.
Thank you.
Yeah, so now we will actually break for lunch. And then we look forward to the quiz program in the afternoon with 5 teams participating. Thank you.
Good afternoon. Hello, am I audible? So we are starting the climate change quiz. We have 5 teams. First is Unique Public School Ooty, Saurish Ashok 10th standard and Samiksha 12th standard. Please come to the stage. Please go to team 1. Please go to here. Please go to team 1. Second team is Holy Innocent School and Junior College, Wellington. Adidev Anup, 10th standard. A. Ranjit, 12th standard. Please come to. Third is JSS Public School, Ooty. Misbah, 11th standard. Madhav Krishna, 11th standard. Team 4, the Lawrence School, Lovedale. Sri Varshan, 12th standard. Bismi, 12th standard. One more team from the Lawrence School, Ananya Bhargava, 12th standard. Agni Dipto, 12th standard. Welcome, all the 5 teams. So we have 20 questions in this quiz. So you have a buzzer in front of you. You have mic also. So I will display one question, and whoever press the buzzer first, it will be displayed on this, and you will get the chance to answer. If you are not answering, the question will go to the audience. If anybody in the audience can answer, they can get a prize. Audience will get a prize. Correct answer will give you 10 marks, and incorrect answer will give you -5. So if you are very sure only, please read the question, understand the options, and then only you press the buzzer. Otherwise you will lose 5 marks. Question number 1, please see the screen. First question on the screen. It's okay. Yeah, we'll go to the second question because first question was already shown on the setup was not correct. So please see the question. No. Don't do that. You are showing the answer. No? You leave it. But it already displayed. It's okay, no problem. Leave it. So question number 2, please see the question. Now. Now it is correct, yeah. So please see the question number 2. First question we cannot go. Team number 4.
Stockholm.
Stockholm is the correct answer. So team 4 will get 10 marks. We'll go to question number 3. Which is the first carbon negative country in the world? Or 1 minute. Yeah. Team 3. Yeah, but in the display 3 is there. Yeah, team 3.
Bhutan.
Huh?
Bhutan.
Bhutan is the correct. Reset. It's working. You press 3. No. Wait. You don't press. Team 3. Team 4. It's working. See, don't press the button. Team 1, please press the buzzer. Press. Two. 3, 4, 5. Yeah, but don't keep pressing. Press and release. If you keep pressing, it will not work. 1 again. 1 more. Coming. So don't keep it pressed. If you are keeping it pressed, others will not get a chance. So please don't keep the hand on the buzzer. Whenever it is needed, you press. Question 4. Which of the following organism is considered as a natural carbon sink in the ocean? Team 3.
Phytoplankton.
Phytoplankton. Fifth question. Which renewable energy is produced by harnessing heat from beneath the Earth's surface? Team 5.
Geothermal.
Geothermal. Now, after 5 questions are over, 1 question is cancelled, so 4 questions are over. Team 3 has 20 points, Team 4 has 10 points, Team 5 has 10 points. Is that right? We're going to question number 6. I used to have a person to help. Today he is not there. So both I have to. Again you press it. Keep the hand away from buzzer. Don't press it. Otherwise it will not reset. Question number 6. Yeah. Who is often called father of climate change science for his work on greenhouse gases in the late 19th century? Team 5.
James Hansen. Option B, James Hansen.
That is the wrong answer. Option B is the thing. 5 will get -5. I think my feeling is that you didn't know the answer. You took a chance. Please don't do that. If you know the answer, please read the question, because before I displayed, you pressed the button. Please read the question, see the answers option. If you are very sure, you press. Question number 7. In 2006, which documentary film on climate change won the Academy Award for Best Documentary Feature? Team 4.
Option C, Chasing Ice.
Huh?
Option C, Chasing Ice.
Chasing Ice is not correct. The Inconvenient Truth. Question 8. Certain coastal ecosystems such as mangroves, salt marshes, seagrass meadows capture and store large amount of carbon in both their biomass and underlying sediments. This is very important process. This type of carbon storage is commonly called by a name. Of team 2, please.
Wetland carbon.
This is called blue carbon. So team 2 will get -5. Question number 9. Arctic amplification refers to. Team 4.
Option C, sea ice expansion.
Option C. You are saying option C. Option A is the correct answer. Question 10. Basa. Question 10. India submitted its long-term low-emission development strategy in COP 727. Which of the following is correct? 1, 2, 3, 4, 5. Which combination is correct? Team 3.
Option D.
Can you tell again?
Option D.
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 D. Yes. Fourth one. It's correct. Now 10 questions are over. According to me, team 3 has 30 points. And team 5 has 5 points. Team 2 has -5. Is that right? $11. Question 11. What is India's equivalent global positioning system known as? Team 2.
Now GP.
Option B you are saying?
Option B.
It's called a NAVIC. Question 12. The 2015 film Aisa A Jahan has something related to climate change. It has a unique claim made with respect to climate change. What it is? If you don't know, I will go to audience. Audience, please raise your hand, backmost row.
Carbon neutral movie.
This is the first India's carbon neutral. Can you introduce yourself? You are from Lawrence School?
Yes.
Yeah, please come.
Go.
Question number 13. Which meteorological phenomenon is defined to cause a rainfall equal to or greater than 100 mm per hour? Team 3, please.
Cloudburst. Cloudburst.
That's right. Question 14. The global methane pledge launched at COP26 aims to reduce global methane emissions by at least % by 2030, which could eliminate over 0.2 degrees Celsius warming by 2050. Team 1, please.
50%.
It's 30%. Question number 15. The Green Credit Program, introduced under India's Environmental Protection Act, incentivizes what? Team 1.
Option A, sir.
Can you repeat?
Option A.
A. A is correct. Now, 3 phases are over. Now, team 3 is 40 points. Is that right? Team 3. Team 1 is 5 points. Team 5 is 5 points. And team 2 is minus 10. Is that right? Huh? Team 4 is 0. Yeah. Now, last segment. Question number 16. Question number 16. Which Indian company signed a 2025 MOU with United Nations to recycle ocean plastic into wearable products? Team 3.
Sir, option A.
Option A is correct. Question 17. Where is the headquarters of International Solar Alliance located? Team 4.
Option D, Bangalore. Option D,
Can you tell the full?
Bengaluru.
Bangalore. It's in Gurugram. Question 18. In which year was the Intergovernmental Panel on Climate Change established? Team 1.
Option A,
Full.
1988.
1988. That's right. Question number 19. Which Indian airport became first to operate entirely on solar power? Team 2.
Cochin International Airport Limited.
Question number 20. Which is the first country in the world to make climate change education compulsory in schools? Team 3.
Finland.
Italy. Correct answer. First, second, third. With 45 points, Team 3, that is JSS Public School, came first. With 15 points, Team 1, Unique Public School, came second. Third prize is Team 5, the Lawrence School. I will ask few questions for the audience before prize distribution.
Excel save ചെയ്തിട്ടില്ലല്ലോ സർ
Section ഞാൻ save ചെയ്തിട്ടുണ്ട് sir. Actually Excel ഇതിലാണ്.
ഓക്കെ
ഇത് update ആവുന്നുണ്ട്. HTML വെച്ച്. First question for the audience. Many people tend to confuse the ozone hole with the global warming. In reality,
Sir B. Sir B.
who has the mic?
One. B.
No, only one answer,
Sir
please.
B. Oh, the cause of increased carbon
Pradeep,
dioxide
who
level in
told
the
first? What is the answer?
B. Answer B.
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 B is not correct. So,
B for ball.
B is not correct. No. We can't give more option because it will be next is A, B, C like that it will come. No, only one chance. Each question only one chance.
Yes, okay, sir.
Okay. So you give the mic to this side front first.
Take it back, sir.
You listen to me. First this side front row. Front row means front half.
Okay.
Next back side. Then this side, this side. 4 we can divide. Huh? It's a separate problem. Actually, this is a separate, primarily a separate problem. What is carbon footprint?
Stand. Sir, option A.
A. A is correct.
Go on, collect the mic.
Next question. What is global warming potential?
Answer D. Excuse me. All of the above. Excuse. C. Is it C? Sir.
No. Who has the mic?
Sir. Sir, all of the
What
above.
is your answer?
Impact of emission of a unit mass of gas related ozone.
C is not correct.
No.
Sir, I told D before.
This is CO2. The reference is CO2. What is the name of UN body of scientists that reviews climate change scientific works to support? UNFCCC.
B.
Please tell full.
International Union for Conservation of Nature.
That's not correct. It's IPCC. I told in my presentation also. Now backside.
Say Egypt.
Okay, fine, my answer.
Brazil.
No. First, you tell the answer.
Wait. Next answer.
El Nino is a weather phenomenon that occurs due to
C. Answer. Weakening trade wind blowing west from
tell the
South
answer.
American towards Asia.
I can't hear you.
C. The answer C.
In a non-rotating Earth, the Coriolis force experienced by a mid-latitude jet stream with a velocity of 100 kilometers per hour.
D. 0.
That is correct.
Should I talk?
The most basic factor causing the distribution of hot and cold temperatures.
Cloud cover.
When the ocean absorb additional carbon dioxide from the atmosphere, this can lead to
Option C. Impact sea level rise.
how many major ice ages have occurred in the past?
Option C. 3.
I think we have to stop there. Okay, two more questions. Arabian Sea is more salty than Bay of Bengal. What is the major reason?
Sea sediments.
Can you tell again?
Sea sediments.
River discharge. Not correct.
Sit and then raise the hand.
What was the main goal of Montreal Protocol?
C.
Ozone. We'll close. I think will close the audience. So now I request Dr. Paramesh to come on stage. Also the headmaster of the school, maybe please come to the stage for prize distribution. Second prize, third prize. Third prize. First prize, JSS Public School, Ooty. Come, sir, you are. Second prize, Unique Public School, UT. Third, the Lawrence School. Minute, sir, 1 minute. Sir, ಇನ್ನೊಂದು ಕಪ್ ಕೊಟ್ಟಿಲ್ಲ ಯಾರು ಒಂದು ಕಪ್ ಇದೆರಡು ಕೊಡಿ.
Participation certificate बोला third prize. अच्छा third prize है third prize को तो सर third prize
Yeah, we have some. We would like to thank the Lawrence School for providing this facility and permitting us to do this very important program. As a token of appreciation, I would like to give a small memento to the Honorable Headmaster. Thank you, sir.
I kindly request the headmaster to give away the mementos to the dignitaries. Professor S.K. Satish, Dr. H. Paramesh, Professor V.S. Jayakumar, Mr. Baby Kuti P. Rajan, and Mr. Jacob George. I now request Mr. Jacob George to deliver the vote of thanks.
Team 2 on a fourth place. We're at the 80 number. Participation certificate for the final quiz.
Come here.
Reversion and Bismi.
More important, huh? Yes.
Thank you all.
Respected Headmaster of Lawrence School, Ooty, the distinguished dignitaries, senior scientists from IISc, Bengaluru, and the staff and students of St. Lawrence School who have been with this event, who have been with us, supporting us, helping us with all what they can. I am here to give the vote of thanks, the last part of this one-day program, initiated and executed by IISc Bangalore. First of all, I extend hearty thanks to Dr. M. Rajivan, who inaugurated this day's event. He has expressed, in a nutshell, he has expressed his thoughts, scientific thoughts about climate change. I am extending hearty thanks to him on behalf of Lawrence School, on behalf of Talentspire, which has organized this, and of course, the entire audience. Thank you very much, Rajivan sir. And Professor S.K. Satish has been with us since morning till now, running the quiz. He is a scientist of energy, new thoughts, and of course, a commitment to the society and commitment to the cause he is working for. Thank you, Dr. S.K. Satish. We has become the hero of the college and hero of the day. And thanks to Dr. J.S., former chairman of the Divecha Center for Climate Change. And of course, Dr. S. Paramesh, he declared that he is 86, but I will say that he is 86 years young. Thank you very much, sir. Thank you, thank you. And we have had other staff, Rajay from IAC, thanks to you all. Of course, we are thankful to the school, that is Lawrence School in Newty. headed by its master. I have been with him for some time today, to him at length, in short. Thabala Venkata Someshwara Ravu. Really a wonderful person. He's very simple. Unlike and too gentle a man, unless the headmasters I have had in my school days. You know, our headmasters, I am from Kerala, in our times, our headmasters used to be crude, tough, because, you know, we were tougher. You know, we could see them only with a long, thick cane in the hand, roaming around the school, looking for mischievous, naughty boys and girls. And he would give us heart beating. Unlike our headmasters, he's too gentle. A soft power in him, a gentle power in him. That's Yes, Bina Varghese, Dr. Bina Varghese. And she is also a powerful lady, she is. And our own people, Matthew John, the president of Talentspire, Professor T.G. Madhuri, she is our subject expert, and Mrs. Meera Nair, and of course, Dr. V.S. Jayakumar. He's full of ideas, enthusiasm, and ambitions. I am concluding my simple speech. Thank you all. Thank you very much, and we look forward to and we all look forward to come back again to see you. Thank you very much.
Class 11 science students to stay back after the program. Let us all rise for the national anthem.